So I'm recording now, guys. So first off, as we look at this, and I realize some of you did this, some of you did not do it, and I appreciate you guys having your microphones muted there. I think, Kate, you're unmuted, so if you don't mind muting. Um, as I look through this first page, were there any questions, concerns, issues that we needed to address in terms of the answers to this? Because I think I went through sort of the highlights on this on a video that was posted yesterday. That would have been Monday, April 20th. But I want to give everyone a chance to chime in if there's something going on. Okay, I'm going to go ahead and go to the next page real quick because we're going to explore a lab today where we kind of build on some of our knowledge. So here, I'll just kind of go slowly here. If there's anything that jumps out at you and you're like, hey, wait a second, speak up. Okay, whole lot of nothing there, which means we either got it or we didn't do it, or it's too early in the morning to talk. And so I'll go ahead and then look at this. This one maybe is a place where you weren't quite sure about some stuff. I'm not sure. So I'm going to be quiet and chime in if you've got something. Okay. All right, so listen, here's what we want to do today. Today is pretty straightforward. It's not going to take too much time. When you go to Canvas, you should see and be able to print out, hopefully, a copy of this. All right. Oh, goodness. Wait a second. This is the lab that you guys did the other day. I got myself all confused. Sorry about that. So if you can go ahead and take a moment, if you have this handy, all right, we're going to run through answers to this. So if I call on you and you don't know, just tell me, okay? So I'm going to you, Adam Fitzsimmons. Is there anything you see in the sim right now that indicates what is moving in the wires when you hook this thing up and you've turned off the show current? Is there anything in the simulation that tells you what's going on in the wires right now?
I'm not sure.
Okay.
But I would say no.
Yeah, so if you've ever looked at an electrical wire, do you see something going on in the wire?
No.
Okay, so that's one of the difficulties in understanding electricity is we can't see what's going on in the wire. And then, so if we can't see anything, is there anything that would indicate which?
Bulb being on be an indicator of what's going on in the wire?
And let's see here, is that Emily?
It's Anna.
Anna. So yes, but if you look at the question is sort of what is moving through the wires? If we only look at the simulation, I know that we know that it's charges moving, that it's electrons moving, but if we didn't know that already, just from looking at the simulation, Anna, would we have any indication as to what it was that was going on in the wires?
You have a battery and 2 light bulbs that lit up. It's probably electricity.
It is, but let's assume that we weren't that smart. If you just look at it, there's nothing that you can tell other than you're like, I mean, it could be dark magic. It could be the dark arts. Who knows? So we're kind of playing along here. We know that something's going on, okay? Obviously, the lights are lighting up for a reason, okay? But without some indication, we don't actually know what's going on in the wires. Is there anything that we see in the sim indicating which direction? And I'm hopeful that if we'd follow the directions here where it said, make sure that this is turned off, then we should have seen nothing going on and nothing going in a certain direction. All right. So let's go ahead and jump on down here. And in hindsight, I realized that the pictures that I had taken had actually recorded the values for you, which was a numbskull mistake. So you should have gotten a 0.45 ammeter measurement there. And then if we go to the next page, we would have had this circuit. And let's see here. Let's see if you guys can give me, if you open up the participants page at the bottom, so take a moment in the Zoom window right now, click on participants. You should see all of us over there. Can you guys use those non-verbal things to give me an indication? Give me a thumbs up, those of you that actually did this lab. I'm kind of curious. So take a moment, click on participants. You click on the little more button that has 3 dots underneath all the participants, and you see the thumbs up. And just give me a thumbs up if you did the lab. I'm kind of curious. All right, so not a ton of folks. So what I'm doing right now is more for the benefit of the video folks. All right,
How
so
do you
then,
do a thumbs up?
so do you see the list of participants there? Have you got that window open there,
Yeah.
Amir?
I ain't got that thumbs up though.
Okay, click on the little window, the little circle with 3 dots that says more.
Yeah.
And now do you see the thumbs
Oh,
up
I
in
got
there?
you. Yeah.
Okay, yeah, it's hidden in there. Okay.
Thank you.
All right, cool. So then if we continue here, now what we've got is we've got 2 bulbs, and what we've got is a current reading, and I'm trying to see here, something is weird. Hang on. Oh, I'm sorry. I got myself all turned around. It's been a little bit of a hectic morning. So what we had was we had 2 bulbs in the first circuit. We have 2 bulbs in the second circuit. And what we're doing is we're putting the ammeter in simply different spots in the circuit. And lo and behold, we get the exact same measurement. And then we go ahead and we rearrange things again. So we do some disconnecting and we do some reconnecting, and we put the ammeter in a 3rd spot. And lo and behold, we get the same measurement. So what did we notice about the current measurements? They were the same everywhere. And so if we did this lab, hopefully you guys concur with those observations. And so now we're doing a little bit of thinking here. So I'm going to call on a couple of you guys here. Let's go over there to Addie. Addie, does it seem like a good indicator that the same amount of electricity is flowing everywhere in the circuit?
Yeah.
Yeah, it absolutely does. Okay, we've got the same amount everywhere, but key point, if we're only looking at that meter, does that alone give us an indication of which direction the electricity is flowing?
No.
No, okay. So no indication of direction without a little bit more information. Good stuff. All right, so then let's see here. We turn on this little box, and now we can quote unquote start to see. And there is a difference between conventional current and electron flow. And I don't want to get too far into the weeds on this. All we're ever going to worry about is conventional current, all right? And so in this particular circuit, if this is my picture and this is the end of the battery, if I draw this a little bit more clearly, this is the one that has the little nib on it. This is positive and this is negative. So if this is the circuit that we have, Addie, I'm going to stick with you there. Was the electricity flowing clockwise or counterclockwise?
Counterclockwise.
Let's see here.
It was clockwise.
Yeah, because it's always going to go from positive to negative. So in this case, that would have been clockwise. All right. And so now we reverse the orientation of the battery. And it said record any differences that you observe in the circuit behavior. Adam, I'm going to come over there to you. So we switched the battery around. Did the bulb still light up?
I'm not sure.
Okay, that's okay. Anna, did the bulb still light up if I just flip the battery around, if it ends up looking like this?
Yes.
Yep, absolutely. So here's a bulb, here's a bulb. And so what did change, Anna?
The direction of the current switched to go counterclockwise.
Good stuff. Switching the battery, switch the direction of the electricity flow. Cool stuff. So based on your observations, which part of the circuit controls the direction of flow? We're going to say that that's the battery. Controls the direction. Does the direction of electricity flow and the amount of electricity flow as measured by the ammeter appear to be the same in every wire? So when we moved the ammeter to different spots in the circuit, let's see here. Emily Larson, I didn't see a thumb on this. Did you do the lab here? Am I asking you a question?
No, yeah, I haven't gotten to it yet.
Okay, no worries. So I won't worry you about that. Anna, did it appear that it was the same everywhere?
Yes.
Yeah. And that's a key point. So it doesn't matter where I am in the circuit, all right? The amount of electricity is always going to be the same, and the direction is always going to be the same. It's always going to be going from positive to negative. All right, some people mistakenly think that charges get used up as they go through a circuit. How does this investigation prove that charges do not get used up? What might you have seen if charge was used up? So if charge was used up, all right, and I just need somebody that did the lab here to chime in with an answer. If charges got used up, what would we have seen in this activity?
The light bulbs probably would have dimmed or gone out.
Okay, we might have seen differences in brightness of the light bulbs. One bulb was brighter than the other, and if you do the lab, or if you remember the lab, the bulbs were the same brightness. What about the meter readings? If charge got used up, would the meters have all been the same?
The meters would have gone down.
Meters would have changed, and bulb brightness would have been different. Bulb brightness would have been different. Okay, so that is the lab that we did. Questions about that? Okay. So now let me go ahead and preview what you're going to be exploring with the lab that's posted for today. And now I need to stop sharing and go over here to, now I think you guys should be looking at my browser. So today we're going to be exploring what a light bulb does. So you will go ahead and you'll get that. And you'll go ahead and print out the lab. And it's going to use, again, the simulation that we've been using. And let's see here. Let me go ahead and pull this up. I'm just going to kind of run you through what you're going to do and the sort of observations that you're looking to make. You'll start out with battery, wire, and you'll put a bulb in there. And you're going to grab yourself an ammeter. And you're going to throw that guy together. And I think, and I'm not doing this exactly as the picture is shown, I'm going to throw a switch in here. And if I disconnect that and I connect this, pretty simple reason that the electricity is not flowing here. Kate, why is the electricity not moving?
Because the switch creates a break.
Yep, I don't have a continuous conducting path. So if I want to turn on and off the circuit, you just click on the switch. All right, and so you can turn it on and off. And the other thing that you're going to do is you're going to change the voltage of the battery. All right, so you will click on the battery itself, and in the lab it tells you to change the voltage, I believe, to 3 volts. And so what we're going to be doing here is we're going to be exploring what happens when we look at a 1 bulb circuit versus a 2 bulb circuit versus a 3 bulb circuit. And so I just wanted to kind of walk you through. I want that undone. Yeah, connect that and get a wire in there. And so I'm just doing this super fast because I know it's about as exciting as watching paint dry, watching Mr. Caldwell build circuits on this. So here's the thing. What we've done is we've changed this circuit and we've changed the number of light bulbs. We're going to make some observations about what we see going on with the current and what we see going on with the bulb brightnesses. That's the first part of the lab. The second part of the lab, you're going to actually take the battery and instead of doing it at 3 volts, you're going to not amp it up, I guess that's not the word I want to use. You're going to increase it to 9 volts. You're going to triple the voltage. And you're going to make some observations, again, 1 bulb versus 2 bulbs versus 3 bulbs. And then when we come back together in I want to say either via video tomorrow or class time on Thursday, we'll put this all together. All right, so at that point, I'm going to go ahead and stop sharing the screen. I'm going to stop recording if I can figure out how to do that. Oh, God bless technology.